Okay, this video is going to be some revision on enlargement part 1. Most of you will not need to watch all of this, but you can skim through it if you need any practice or any further support with some of the examples here. So I'm just going to get on straight with the examples. Obviously, it's best to try these before I actually show you the answers here, otherwise it becomes a bit pointless just to watch the videos, watching me doing the work. So unless you need help, obviously. So enlarge the shape by scale factor 3 about the center 9, 1. So I'm going to go 9 across, 1 up, and then the scale factor is 3. So I'm going to pick the top vertex here, so you can see I'm going 2 up. Now if my scale factor is 3, I'm going to need to go another 2 times. So I've got 1, 2, 3. That's my new vertex here. Now at this point I probably can just sketch the whole of the shape from here, because if I know that's my side length is 6, well the top is also going to be 6 units wide because it goes from 2 times 3 is 6. That length is 1 down, so it's going to be 3 down. That length is 3 across because the original is 1, and then you can see I can just fill out my shape. You've got your enlargement. Okay, next example. Enlarge by a scale factor 2 about the center 7, 8. So 7 across, 8 up. So this time the center of enlargement is inside the shape. So in this case I'm going to go from the center of enlargement to a vertex. I can see I'm going one diagonal. Now I need to do it twice because I'm enlarging it by 2. So that's my vertex of that shape. Now in this case I'm going 1 to the right, 3 down, 1 to the right, 3 down. So that's my other vertex. So I'll label those 2. And then I'm going to do this vertex here. So it's 2 right, 1 down, 2 right, 1 down. I'm doing it twice because the scale factor is 2. And then I've got, at this point we're probably ready to sketch the shape out, because we can see if I've got this corner vertex here and I know that that length across the top is 2, now scale factor is 2, well that means that length becomes 4. Now if I go 1 across, 2 down, well that's going to mean instead I should go 2 across, 4 down. So 2 across, 4 down, which I've already got here labelled. And then here it's got 2 down, 3 across. So I'm going to go 2 down, 3 across, 2 down, 3 across, and then I'm just going to join this up. So there's an example here where your center of enlargement is inside the original shape. Next example, enlarge the shape by scale factor 2 about the center -5, 4. So -5, 4, so that's our center of enlargement. So now we need to go from the center of enlargement to the shape and then do that twice in each case because the scale factor is 2. So there's 1, 2, so that's going to move there. Now actually, again, we can just draw the shape out. We know it's going to be twice as big, this new triangle. So if the height of the original black triangle is 2, the height of our new triangle is going to be twice as big as 4. If the base length is 3 here, then the base length of our new triangle is going to be 6. And then we've got, we just connect those two together. We've got our enlargement. Okay, question 10. Describe the single transformation from A to B. So we're going to need to draw the ray lines again. So find the corresponding lengths and just keep extending the lines here. So I predict it's probably going to end up being here for all of them. So here again, corresponding lengths, and then just extend it, corresponding vertices, and then extend it, and you've got your answer there, which is 0, 6. Now your answer has to have 3 parts. You have to say it's an enlargement, you have to say what the scale factor is. So the scale factor goes, the length here, we're going from A to B, remember, so it goes from 2 to 1, 2, 3, 4, 5, 6. So the scale factor is 3, it's 3 times bigger, and the center of enlargement is 0, 6. So there's your solution written out. You must mention all of those things. Okay, question 11. This time we're enlarging by a scale factor 3, about the center 3, 14. So 3 across, 14 up. So there's our center of enlargement. So if I'm going from my center of enlargement to that vertex, I am crossing over 1, 2, 3, 4, 5 units. Now if my scale factor is 3, I'm going to need to go 15 units. So that's 5. Then go another 1, 2, 3, 4, 5. And then another 5. 1, 2, 3, 4, 5. Now again, if I know that's the top, if the corresponding vertices are there, well, that top length is 1 unit, and that's going to become 3 units. If that length is 1 unit down, I'm going to go 3 units down. And then we can draw the rest of the shape out, which I'll do carefully here. And then 2 units down, so that's going to become 6 units down. So 1, 2, 3, 4, 5, 6. I've got 1 across, so that becomes 3 across. And then I'm going to go 3 up, 3 across, and 6 up. And there is your enlarged shape. Question 12. Describe the single transformations from A to B. So I'm going to go from A to B. So let's do it this way around and see what happens. Okay, so this is going to go this way. That vertex lines up with that one. I think I got this bit wrong here, so actually I did the wrong vertex, so that should actually go through here, and this should go through here, this should go through here. Actually we found our point, so that should be enough pretty much. It's going to be 6 along, 0 up. So there's a couple of, remember the 3 things. First of all, we're going from A to B, so it's an enlargement of the shape. The side length goes from 1 unit to 3 units. So the scale factor is 3. Center of enlargement is 6, 0. So there's your answer. Scale factor 3, center of enlargement 6, 0, and it's an enlargement. So those are the examples for the last part of enlargement 1. We're going to follow in with enlargement 2, which is where we look at scale factors which are fractions, and also scale factors which might be negatives. So I'll see you in that video. Hit subscribe, smash the like button.